Welcome to the session on straight line graphs, parallel and perpendicular lines. The objectives for this session are to know and use the rules for parallel gradients and know and use the rules for perpendicular gradients. The equation of a straight line is given by y equals mx plus c. Suppose a straight line with gradient m passes through the point x1, y1. If xy is a general point in the line, then recall that m, the gradient, is equal to the change in y minus y1, over the change in x minus x1. Parallel lines have the same gradient. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. Suppose that a line is parallel to 5x plus 6y minus 3 equals 0 and passes through the point 1, 2. Find the equation of this line. So let's solve this. Now the equation of the line is 5x plus 6y minus 3 equals 0. So rearranging gives 6y equals 3 minus 5x. We're trying to isolate the y's. And then dividing through by 6 gives y equals a half minus 5/6 x. Notice that minus 5/6 is the gradient. So the equation of any parallel line takes the form y equals minus 5 over 6x plus c for a constant c. We will input x equals 1, y equals 2 in this equation. X equals 1 here, as shown, and y equals 2 here. Then rearrange to give c equals 2 and 5/6, or 17 over 6. Therefore, the equation of the line is y equals minus 5 over 6x plus 2 and 5/6. Perpendicular lines are at right angles to one another. So suppose L1 and L2 are perpendicular lines with gradients m1 and m2. Then m2 equals minus 1 over m1, or equivalently, m1 times m2 equals minus 1. Notice that this holds because the triangles are congruent, so the gradient of L1 equals a over b, and the gradient of L2 equals minus b over a. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. We will now have a go at example 2a. Work out whether the following pairs of lines are parallel, perpendicular, or neither. Y minus 2x minus 5 equals 0 is line 1, and 7y minus 14x minus 3 equals 0 is line 2. So let's solve this. We are going to find the gradients of both lines, and we will do this by rearranging them in the form y equals mx plus c. So let's rearrange line 1. We're going to add 2x plus 5 to both sides in order to isolate the y on the other side. So y is equal to 2x plus 5. And the gradient of line 1 is 2. Similarly, we're going to rearrange line 2 so that the y is isolated on the left-hand side. We're going to add 14x plus 3 and divide through by 7 to give that y is equal to 2x plus 3 over 7. The gradient of line 2 is therefore also 2. Since the gradient of line 1 is 2 and the gradient of line 2 is 2, And since parallel lines have the same gradient, we can therefore deduce that the lines are parallel. And now for example 2b. We are required to find out whether the following pairs of lines are parallel, perpendicular, or neither. 2y minus 6x minus 5 equals 0 is line 1. 15y plus 5x minus 3 equals 0 is line 2. So let's solve this. Again, we're going to find the gradient of both lines. So let's rearrange line 1 to give y equals 3x plus 5 over 2. So the gradient of line 1 is 3. Similarly, let's rearrange line 2 to first give 15y equals 3 minus 5x. Notice that we've added 3 minus 5x to both sides in order to isolate the y's, and then divide through by 15. Therefore we have y equals 1 over 5 minus x over 3. And therefore the gradient of line 2 is minus 1 over 3. But we know that the gradient of line 1 is 3. So if we multiply the gradients, 3 times minus 1 over 3, we have minus 1. And therefore the lines are perpendicular. Now let's take a look at example 2c. Work out whether the following pairs of lines are parallel, perpendicular, or neither. Line 1 is given as y equals 5x, and line 2 is given as 3y minus 9x minus 1 equals 0. So let's solve this. Line 1 is already in the format y equals mx plus c. Therefore the equation y equals 5x has gradient 5. We need to rearrange line 2. So let's rearrange by adding first 9x plus 1 to both sides in order to isolate the y's. We therefore have 3y equals 9x plus 1, and then divide through by 3. So y is equal to 3x plus 1/3. And therefore the gradient of line 2 is 3. Since the two gradients are not equal, the lines are not parallel. Let's try multiplying the two gradients. 5 times 3 is 15, and therefore clearly not equal to minus 1. So we can conclude that the lines are not perpendicular either. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So example 3 says that suppose a line is perpendicular to the line 3y minus 2x plus 5 equals 0 and passes through 3 minus 2. Find the equation of the line. So let's solve this. We will rearrange 3y minus 2x plus 5 equals 0 in the format y equals mx plus c. So first let's add 2x minus 5 to give 3y equals 2x minus 5. And then divide through by 3 to give y equals 2/3 x minus 5 over 3. Therefore, a line which is perpendicular to this has gradient minus 3 over 2, because 2/3 times minus 3 over 2 is equal to minus 1, as shown. So the equation y equals minus 3 over 2x plus c is perpendicular to our line for some constant c. However, we know that the point 3 minus 2 passes through this line. So let's input y equals minus 2 and x equals 3 into our new equation. to give minus 2 equals minus 3 over 2 times 3 for x equals 3 plus c. And therefore we can rearrange this to solve for c. And therefore we have that y is equal to minus 3 over 2x plus 5 over 2 is the line which is perpendicular to our line 3y minus 2x plus 5 equals 0. This brings us to the end of this session. If you have understood its contents, you should be able to know and use the rules for parallel gradients and know and use the rules for perpendicular gradients also. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.